Hello everyone, this is the video for my environmental science class. We are in Unit 5, so we're talking about the atmosphere, we're talking about the hydrosphere, we're going to talk a little bit about climate and climate change at the end of this unit, but today we're going to talk about the main causes of air pollution. And air pollution is a little bit of a vague term because it's really anything in the air that's not supposed to be in the air, right? Or anything in the atmosphere that's not supposed to be there, especially those things that might cause a harmful reaction to the people that live around that area or the environment itself. So, primary pollutants versus secondary pollutants is the first big differentiation we need to make. So, primary pollutants are the things that are introduced to the atmosphere that are not supposed to be there, period. Secondary pollutants are a thing that happens or a result of those primary pollutants reacting with things in the atmosphere. So when something is introduced to the atmosphere that has a chemical reaction with something that's already in the atmosphere and it causes a different pollutant. Two primary pollutants that react together to form something else also make a secondary pollutant. All right. So this picture here of a smokestack dumping a bunch of smoke out of it, that's a primary pollutant, right? The largest source of air pollution in the world, not just the US, is industry. So factories making things. This picture below is a coal-fired power plant. So we're including making energy, right? Making electricity in this. The other one is vehicles, especially larger vehicles dedicated to transport of goods. So we're talking trains and semis, tractor trailers, that kind of thing. The long operation times of them, especially with the lower efficiency that is prevalent among those types of vehicles, means that they dump a lot of pollutants into the atmosphere. Right. So one of the problems with air pollution is that sometimes things go awry and magnify the actual symptoms of that air pollution. So under normal conditions, right, it gets hot at street level, let's say in a city. And as that heat radiates out from the city, it gets colder and cools down, especially as it increases in elevation. Sometimes a pocket of colder air will settle on a city while the warm air still rises up through it. This causes what's called a temperature inversion. Inversion means switching it, right? So you can see in this picture here, this one, normal conditions. This one, we get that reverse, right? Warm air up here instead of down here. This traps a lot of atmospheric pollutants and can cause a buildup of smog. Right? So smog is any pollutant that gets trapped at what we consider the important part of the atmosphere because it's where we live, right? So this happens specifically in cities. Temperature inversions can happen everywhere, but they happen a lot more frequently in larger cities. Smog also can happen wherever human populations are, but again, much more likely in a larger city as opposed to a small town or village because there's just more heat and more air pollution. Smog is a big problem in some of the largest cities in the world. It causes a lot of health problems and has caused cities to effectively shut down in the past, telling people you have to stay inside, you have to make sure that you wear a mask when you go out in public and not just one of the masks that, in these times, right? I'm recording this in 2021. We all know what's happening out there, right? Not just that kind of mask, but a particulate mask that will help to filter out a very, very tiny molecule. Right? Smaller than a virus. Right? In the past, and currently, one of the large impacts of pollution has been affecting the ozone layer, specifically something called a CFC, or a chlorofluorocarbon. So this is chlorine and fluorine bonded to a long string of carbon atoms. So this is a big molecule as far as molecules are concerned. And when it is released and enters the atmosphere, it rises. And as it rises, it effectively will continue to go up and up and up until it reacts with ozone. That's O3, three oxygen atoms bound together. And it can react with the ozone that is in the ozone layer and trap that ozone or remove that ozone from the atmosphere. So the ozone itself is less dense in a specific location. One of the locations for this has been close to the South Pole and Australia. In 1997, a international agreement was reached called the Kyoto Protocols, where nations agreed to stop producing or greatly reduce chlorofluorocarbon emission and the production of products that would emit chlorofluorocarbons. Chlorofluorocarbons were very prevalent in refrigerants and in things like aerosols. So hairsprays, spray-on perfumes and colognes, and sometimes even spray paints. So a lot of things had to change so that chlorofluorocarbons and a few other pollutants weren't being emitted as much. Here in the US, the EPA regulates what emissions can be made through vehicles and industry. So the EPA is who actually enforced the US's agreement with the Kyoto Protocols. And it has levied fines and shut down specific factories because of breach of the Kyoto Protocols. Most of the time, those factories are reopened after, let's say, a new filter is put on a smokestack or a change in the actual production line so that chlorofluorocarbons are no longer produced as much or at all. Right now, the ozone layer is starting to rebound, and within the next 10 years, I believe it is predicted to go back to, I think it's the pre-1960s. Don't quote me on that. I'm not great with years, but about the 1960s levels, which is a good thing. All right. The big one that everybody talks about, but here in the US we don't have very much of at all, is acid rain. Acid rain is a thing that happens because of those secondary pollutants, right? So we've got specifically nitrates and sulfates that are emitted from industries or from residences, burning trash, that kind of thing. And as they rise, they actually react with the normal condensation that happens. And they lower the pH of the condensation and the precipitation that occurs later after, condensation. Remember the water cycle? We talked about it a few weeks ago or videos ago, depending on how you're watching these. And as the rain or snow, you can actually have acid snow as well, it will create an area on the land where plants will die. Statues, cement can be damaged. Blacktop can be damaged as well, as though asphalt is a little bit more tolerant to acid rain than concrete. And then after the precipitation, the clouds can also dissipate and deposit dust particles or pollutant gases farther downwind. As the acid rain can also run off into lakes, or it can infiltrate the soil and actually cause large lasting damage to an area. Acid rain has been reduced because of a reduction in nitrate pollution and sulfate pollution, but it is still a thing that happens, especially in third world countries or second world countries that don't have the large regulatory agencies that have a goal of protecting the environment. Right. Two other types of atmospheric pollution that we don't quite think about as much are noise pollution and light pollution. Noise pollution is defined as any regular exposure to a loud noise. Loud noises is kind of vague though, so let's put a number on that. About 70 decibels. If you walk down a busy street or next to a highway, you are going to hear traffic, right? That's about 70 decibels. Running a vacuum cleaner and being close to it, like within a few feet, that's about 70 decibels. Close to a running dishwasher or a washing machine or a clothes dryer, again, we're talking close proximity, so within 5 feet or so, you might get volume levels up to 70 decibels. Now, if you live in a rural setting, you're not going to get exposed to as much of these noises. But if you live in a tighter density, couldn't think of the word there for a second, population, especially in an urban city, this might be a regular occurrence to you. I've lived in an apartment where I heard traffic like all the time because it was close to the freeway. But, I had a few walls between me and it. Could still hear it though. So noise pollution has a big impact on people over long term. One of those things is lower sleep quality and anxiety, just like light pollution, which we'll talk about later. It can cause long term hearing loss if it is very regular exposure or it's a higher decibel level, so it's louder. Animals, however, that live in the area, also experience these things, and it can have some poor impacts on their behavior as well as, let's say, mating practices, and could have a bigger impact on their population as a whole. Light pollution is having too much or the wrong kind of light someplace it's not supposed to be. Oh, I noticed I have a typo on this page. That S should be lowercase. I'll fix it in my slides later. So some light is okay, but having a lot of light can be a bad thing. This picture below me, you can see two different instances of a very similar sky location. One is taken close to generally close to a city, but we're talking within 50 miles of a city. One is taken about 200 miles from the closest large city. There is a village close by, and if you look kind of towards the bottom right, you can see that a little bit. But this is a difference in what should be effectively the same view. You may not be able to see it very well, but there is a star right here and a star right here. Those are the same star. Much difference in brightness. And then all these other stars, you just can't see at all, hardly. So light pollution affects the atmosphere as light leaves the source and bounces down off of those particles in the sky, usually water vapor. And it causes a glow almost in the sky. And this can disrupt ecosystems by just affecting the actual expectations of plant life on light levels. It can also disrupt sleep in animals and humans, right? It can cause problems with people trying to navigate via the stars. That's a thing that has happened in the past. It doesn't happen as much now because we have things like GPS and much better maps, but it is a thing that has happened in the past, so I wanted to bring it up. In humans, this has caused anxiety. We've done a few studies on this. Anxiety, medical defined stress, and lower quality sleep are symptoms of having too much light in an area. So it's one of the reasons that they say you should try to sleep in a very dark room, not with the lights on all the time. And this is another problem that we're starting to see as cities move from incandescent to LED street lighting, where the light color is shifting from a warm reddish tone or yellowish tone to a blue tone, because that blue light can affect something called circadian rhythm. Circadian rhythm is how individuals, not just humans, but across populations, regulate their own personal sleep patterns. And that can cause larger problems like nocturnal animals not thinking it's night. and having a shift in their own sleep schedule, so they're not asleep when they are normally, and it causes different competition relationships than they would historically have had. Right. So, main causes of air pollution. Remember, we're talking mainly industry and large vehicles, especially those things like trains and semi trucks or tractor trailers. We also talked about a few other types of air pollution. We're going to go over a few different types in my class, at least, as the week progresses and we move through some classwork. As always, keep learning and keep asking questions.